For this section, we'll explore word problems, specifically word problems that can be modeled using rational equations. This first problem is called a number problem, and these are the most boring type of word problems because they're not directly applicable to anything, but they're just used to illustrate a concept. So we have here that one number is 3 times another. The sum of their reciprocals is 4/3. So we just have to find the numbers. So going through this, let me get out my pen. So going through this, we see we have one number. Let me circle that. Is 3 times another number. We can put this in a mathematical sentence. Let's call the first number x, and you can call it anything you want, but I'll just call it x. And we're saying is, so that means equals, 3 times, so that's just 3 times, another number, and we'll call the other number y. So our first number is x, and our second number is y. Now it says the sum of their reciprocals is 4/3. Well, the reciprocal of the first number would be 1 over x, and the reciprocal of the second number would be 1 over y. And that has to be equal to, remember is just equal to 4/3. So let's put those two facts together. So our first equation is we have x is equal to 3y. And our second equation is the sum of their reciprocals, sum just meaning add. So it's just 1 over x plus our second number is 1 over y. Be careful here, it's not 3y. Our second number is just y, equals 4/3. This is the hardest part of the question, just actually setting up the equations. But as long as you just take it slow, you'll get it and assign the variables. Okay, so we know that, so this is the equation we want to solve, this 1 over x plus 1 over y equals 4/3. But we have two different variables in here. We have an x and we have a y, but we know that x is equal to 3y, so we can just plug that in. So let's do that. So rewriting this, we have that instead of 1 over x, we can write this as 1 over 3y plus 1 over y equals 4/3. So we're now down to just solving a rational equation. And the easiest way to do this is just to find the LCD, the least common denominator, and multiply both sides by that. Well, here we have a 3, here we have a y, so we can write those 3 y's in here. Then this one has a denominator of a y, but that's already included in 3y. And this one's a 3, but again, that's included in 3y. So this is our LCD. Let's multiply both sides by that LCD. So I'll multiply the whole left-hand side by 3y, and the whole right-hand side by 3y. And then we just have to distribute. So 3y times 1 over 3y, well, the 3y's would cancel and just give you 1. 3y times 1 over y, well, the y's would cancel, and that would just give you 3. And you're welcome to actually write that out if you like to. For the right-hand side, we can actually just cancel things if we like, because there's nothing to distribute. The 3's would cancel, and we're just left with 4y. To simplify, we get 1 plus 3 is 4, so 4 equals 4y. Now we can just divide both sides by 4 to solve for y, and we get that y is equal to 4. Well, the question actually asks us to find the two numbers, right? Find the numbers. So we have to find both numbers. We only found one of them. Well, if y is equal to, oops, not y is equal to 4, y is equal to 1, right? 4 over 4 is just 1. Sorry about that. All right, so if we know y is equal to 1, we can actually say, okay, we know that x is equal to 3y. So that means x must be equal to 3 times 1, which means x is equal to 3. So those are our two numbers, 1 and 3. We can check this if we like, but those are our answers. Our numbers are 1 and 3. To check this, well, let's look at the original problem. It says one number is 3 times another number. Well, definitely, right? 3 is 3 times 1. So that works. It's 3 times the first one. For our second part, it said the sum of the reciprocals is 4/3. Well, the reciprocal of x is 1/3. the reciprocal of 1 is actually just 1, or we can write it as 1 over 1 if we like. And this has to be equal to 4/3. Well, 1 over 1 is the same thing as saying 3 over 3, because 3 divided by 3 is 1. And now, since they have the same denominator, we can add the numerators, and we get 4/3. So 4/3 is indeed equal to 4/3, so this is correct as well. So these are our answers. Our two numbers are 3 and 1. Let's move on to this next problem. It says a boat can travel 15 miles per hour in still water. If it takes the same amount of time for that boat to travel 2 miles downstream as it does to travel 1 mile upstream, find the speed of the current. Okay, before we begin this problem, let's just go over a brief concept here. Whenever we have a problem that deals with speed of something traveling through either water or air, when you're having a current or a wind you have to face, this is how it works. If a boat is traveling, for example, like 10 miles an hour in still water, then then if there's a current that is added, the current's either going to help or hurt the boat, and it works in an additive fashion. So suppose the boat is traveling with the current, and if the current's going 2 miles an hour, then the boat will be traveling a total of 12 miles per hour, just 10 plus 2. And if the boat is traveling upstream or against the current, then it would be 10 minus 2, so 8 miles an hour. If there's a plane question, it works the same way. A plane going with the current is said to have a tailwind, and against the current, or wind I should say, would have a headwind. All right, so let's go back to our question. A boat can travel 15 miles an hour in still water. If it takes the same amount of time for the boat to travel 2 miles downstream as it does to travel 1 mile upstream, find the speed of the current. That's a lot of information, but one thing that I'm getting out of this is that it takes the same amount of time, right? It takes the same amount of time for it to travel upstream and downstream. So the two times are equal to each other. So time downstream equals time upstream. We are missing one piece of information. There's an important formula when dealing with these kind of problems. We know that distance equals rate times time. And that's just an important formula that you should know. And this is actually a formula you do know. Like if a car is traveling 60 miles an hour and you travel for 2 hours, you traveled a total of 120 miles. So rate or speed, right, would be 60 miles an hour times 2 hours. That gives you a total of 120 miles. We can actually rewrite this formula, and that will help us for this problem because really we want to solve for time because these two times are equal to each other. So we know time, if you divide both sides by r, is just going to be the distance you travel divided by your rate of speed. So we're going to use this formula for this problem. Time downstream. Okay, well, that's just going to be the distance you traveled downstream, which we supposedly traveled 2 miles downstream, divided by the rate of speed. Okay, well, the rate of speed is going to be the 15 miles an hour plus whatever the speed of the current is. Let's call the speed of the current c, just so we know it stands for the speed of the current. So that means it's going to be 15 plus c is our speed traveling downstream, and we did 2 miles downstream. And that has to be equal to, because that's what we wrote there, to the time traveled upstream, which is, we did 1 mile upstream, and this would be 15 minus c since the current is working against us. So we could multiply both sides by the LCD to solve. Another way to do this is to cross multiply. So we can just cross multiply to solve this. And the reason why we can just cross multiply is because we have a single fraction equal to another single fraction. So that just makes this a little bit easier. But if you're not comfortable doing that, you can always just multiply by the LCD, which would be 15 plus c times 15 minus c, and you'd wind up in the exact same place. So let's do that. So it's going to be 2 times 15 minus c equals 1 times 15 plus c. So let's distribute. 2 times 15 is 30, and 2 times c is just 2c. and this has to be equal to 15 plus c. Okay, so let's get the variables on one side, the numbers on the other. I'll subtract c from both sides and subtract 30 from both sides. So now my c's are all on one side, and I get negative 3c equals 15 minus 30 is negative 15. Divide both sides by negative 3, and we get that our current, C, is equal to negative 15 divided by negative 3, which is just 5. Since these were all measured in miles or miles per hour when we dealt with the time, this would be 5 miles per hour. That's the speed, not time, I should say. That's the speed of the current, is 5 miles an hour. Okay, let's work on another question. This kind of problem is called a work problem. These are really, I think, the most interesting and most fascinating problems. And the reason why is because your initial instincts are not going to work out, and you'll realize really quickly why not. It says Todd can paint a room in 4 hours and Diego can paint the same room in 6 hours. How long will it take them if they paint the room together? Now, normally when you do things together, you just add. But if we think about it, 4 plus 6 is 10. There's no way it's going to take them 10 hours to complete the room if one person can do it in 4 hours. So we have to find another way to do this. And another way we can think about this is the amount of work done each hour. Together we want to find how long will it take them if they work together. And so really we want to solve for a time here. We want to find the combined time it will take them to work together. Okay, so let's look at what's done maybe each hour. Each hour, Todd is going to paint 1/4 of the room because he can do a total room in 4 hours, so each hour he must be doing 1/4 of that. So in other words, just take the reciprocal. We could do the same thing for Diego's work. Since Diego takes 6 hours to complete a room, he would do 1/6 of a room in an hour. And in total, their combined work, we don't know how much their combined work is going to be or how fast they're doing it, but we do know that if they're taking t hours to do the combined work, that they must be doing 1/t each hour. This is our equation. There's several ways we can work on solving this. One way would be just to find the LCD and multiply both sides by that. So our LCD, let's see, 4 goes into 12 and 6 also goes into 12. So just looking at the number parts, it would be 12. And then we still have that t over there. So again, just take all the denominators, find something that, find a number that all those numbers go into, and it would be 12t. Let's multiply both sides by that 12t. And again, don't forget to distribute. So 12t times 1/4. Let me write that step. Plus 12t times 1/6 equals, well, there's nothing to distribute here, so we could just cancel out these t's if we like, and we just get 12. Okay, let's continue solving in this. 12 times t divided by 4, well, 12 divided by 4 is just 3. And t divided by 6 is just 2. So rewriting this, we have 3t plus 2t has to be equal to 12. So now we can just combine like terms, and we get 5t is equal to 12. Divide by 5 on both sides, and we get that t is equal to 12 divided by 5. Or if we put this as a mixed number, let's see, 5 goes into 12 2 times, and it would have a remainder of 2. So it'd be 2 2/5 hours. And while this is correct, hours are usually expressed in hours and minutes. So it's really 2 hours and 2/5 of an hour. So if you want to break that down, 2/5 of an hour, well, an hour is 60 minutes. So we can just multiply it by 60. 60 divided by 5 is 12. So therefore, we get 24 minutes. So it's 2 hours and 24 minutes if we wanted to express it the way most people would. And that's our answer. I would definitely accept 2 2/5 hours on a test though. Or even 12/5. Okay, let's move on to the next problem. It's really the same kind of problem, but a different piece of information is missing. It says here that one pump can fill, it's supposed to be fill a pool, not fill a pump, in 5 hours. Well, when the second pump was added, the pool was able to be filled in 2 hours. Let me fix that one word. So it's not supposed to say pump here, it's supposed to say pool. All right. How long would it take the second pump to fill the pool if it was the only pump used? So using the same logic, the first pump can fill the pool in 5 hours, so therefore it could fill 1/5 of a pool each hour. When a second pump is added, it can then the total time is 2 hours. So that means that working together, half the pool is filled each hour. So what we don't know is how the second pump works. So we don't know about the second pump here. How long would it take for the second pump? This part here, this would just be, we can call T instead. And again, this time T, instead of being the total, is just the time it takes for the second pump to clear the pool. Using the same logic, our LCD is going to be 10T, and we can multiply both sides by 10T. Let's distribute 10T times 1/5. Well, 10 divided by 5 is just 2, so this gives you 2T. 10T times 1/T, well, the T's would cancel, and you're just left with 10. And then on the right side, 10 divided by 2 is just 5, so we're left with 5T. Let's move the 2T over to the other side by subtraction, and we get 10 is equal to 3T. Divide both sides by 3, and you get that T is equal to 10/3, or 10/3 of an hour. Okay, 10/3 of an hour, again, even though this is the right answer, it might be best to express this as a mixed number. So 10/3 of an hour, well, 3 goes into 10 3 times, so it would be 3 hours, plus an extra 1/3 of an hour. Well, 1/3 of an hour, there's, remember, 60 minutes in an hour, so 1/3 of 60 minutes would just be 20 minutes. And that's our answer, 3 hours and 20 minutes.